Hey everyone, welcome to my channel. So as I have said that we will be doing the Akash test series, and now let's begin it. So the first question itself is here, and let's see what it is saying. A body is displaced from x is equal to -1 to x is equal to 2, and a variable force is given by the effect of a force Fx square minus 2 newtons acting along x-axis. Work done by this force we need to find out. Okay, so let's take a blank screen. Okay, yeah, can do it here. Okay, so let's see. A variable force is given, that is, and work done is nothing but force dot displacement, and whenever something is in multiplication you have to take integration. Okay, so what the force given is, force is 5x square minus 2, so 5x square minus 2 into dx. Okay, this is -1 to +2, isn't it? And check here. So 5x cube, so 5x square minus 2 was given. If you integrate it, you can write 5x cube by 3 minus 2x, you can write, isn't it? This you can write, and now substitute the values of +2 and -1 and then subtract it. You will be with the answer. Okay, so look at here, I'll be doing here. Let's see. So the question is, now what we have to do, we have to just substitute the values. Instead of x we will be writing 2, so 2x cube will be 8 by what is that, 3 minus what is here, 2. What is here, 2 into 2, 2x was there. Okay, minus of what is that, 5 into -1 whole cube by 3, and here -2 into -1, isn't it? Is it this one only, guys? Yeah. Now let's write it here. Let's solve this. 5 8s are 40 by 3 minus 4 minus of 3 and minus 5. This will be minus of minus plus 2. Okay, plus 2. So now we need to solve this. So how to solve this? So solving it further, like we were here, right? This step we reached, right? Now if you solve this in this part, let's see, that will be 40 minus 12 by 3 minus of 1 by 3. Okay, so this will be what, this will be 28 by 3 minus 1 by 3, that will be 27 by 3. 3 9s are 27. I think the answer might be 9 joules. Let's check it. So yeah, answer is 9 joules. The correct option is option B. The next question, let's see, it's from electrostatics, and guys, don't bother what is below, what it is popping again and again. Do not bother about it. Just see what is happening here. Consider the following statements you have to consider, and what it is saying. Electrostatic field lines do not form any closed loops. Okay, do not form any closed loops. Electrostatic field lines do not form any closed loops. Okay. In a charge free region, electric field lines can be taken to be continuous curves without any breaks. Okay, so they are saying that which of the following option is correct. So if you see that electrostatic field lines, really they do not form any closed loops, because this happens in magnetic field lines, where they originate from one pole and terminate on the other pole, so they form a closed loop. but here they do not form. Once suppose there's a positive charge here and they'll be radiating like this, they do not form any closed lines. No. In a charged free region, electric field lines can be taken to be continuous curves without any breaks. So charge free region, electric field lines can be taken as continuous curves without any breaks. That is also true. So both statements are true, guys. So our correct option is what? Option number 4. What is the first option? First option is electrostatic field lines do not form any closed lines. That is statement 1. That is absolutely correct. And in a charge free region, electric field lines can be taken to be continuous curves without any breaks. That is also correct. So let's see for the next question. Charge Q is given to a conducting shell of radius r such that it has surface energy charge density sigma. Which of the following is the correct expression of the electric field intensity just outside the shell? Okay. So there is a charge Q and it is given to a conducting shell. There is a conducting shell. Conducting shell is nothing like a hollow sphere where the charge is at the surface. Its surface charge density is sigma. Which of the following correct expression of electric field line intensity just outside the shell? Just outside the shell means, like, let's suppose at the surface itself. The surface itself is just outside the shell. So let's see the options and let's match one answer. So you know, electric field line is nothing but kq by r square, isn't it? Kq by r square. Just outside the shell. Let's consider outside the shell means at the surface. So let's take it as capital R. And you know what? Sigma is nothing but charge by area. Area of the sphere is 4 pi r square. So can I write Q value in terms of sigma, or else can I replace this Q by r square by the sigma, 4 pi sigma? Okay, let's check it. So let's do it some blank space here. Yeah, yes. So electric field is nothing but kq by r square. Kq by r square, and sigma is nothing but charge upon area, 4 pi r square, and k is nothing but 1 by 4 pi epsilon naught q by r square. So can I replace q by r square 4 pi epsilon instead except epsilon naught q by r square and 4 pi I can replace with sigma? So can I do it? So yes, I can do it. So what it will be then? It will be like electric field is equal to, I'm replacing all that part, so it will be 1 naught, instead that I will write sigma by, only epsilon naught was left, so sigma by epsilon naught. So let's see, is there any option? Yes, so the correct option is see, our answer is sigma by epsilon naught. Let's see the option number. So can I write in terms of kq by r square also, sigma by epsilon naught also? Both 2 and 3 are correct. This cannot be, this can be in case of potential, not in case of electric field. Okay, so this is the fourth option is the correct answer. So guys, I will be doing 5 questions set, so that it will be short and sweet video and you can complete it 5. Even when you're taking breaks, when you're getting exhausted and you're thinking what to study, what time I should study, how can be productive, like that. So whenever you're getting bored or getting an anxiety, then you can watch this videos. These are going to be really helpful for you. So let's see the remaining thing. So the contribution of electric field in energy density of an EM wave is U. Then half of the contribution of the magnetic field in average energy density of the EM wave will be. This is a very important question. See, so many institutes are repeating this question. That is very important. So you don't avoid it. Okay, the contribution of electric field in energy density EM wave is U. Okay, half of the contribution of the magnetic field in every energy density will be how much? So see, if the contribution of electric field in energy density of an EM wave is U, then half of the contribution of magnetic field in average is half of the contribution. So see, if electric field is U, then magnetic field will also be U, isn't it? And they are saying half of the contribution, so do U by 2. So can I say the second option is going to be our answer? Yes. See, in energy density of EM wave, electric field will contribute U and magnetic field will contribute U to U, right? So, but he is saying if electric field is contributing U, then magnetic field, of course we know that contribute U, then it is saying half of the contribution magnetic field will be U by 2. I hope so you got it. So let's move to the next question. An unpolarized light beam of intensity I is incident on a polarizer, and then it passes through an analyzer which has an axis perpendicular to the polarizer. The field intensity of the emergent beam is. So see guys, this is polarizer. Polaroid is very important, polarization is very important. So see, an unpolarized light beam is there, its intensity is I on a polarizer, and then it passes through an analyzer which has its axis perpendicular to the polarizer. Okay, the field intensity of the emerging beam. Okay, polarized light we need to find out. So you can apply this formula, I is equal to I naught cos squared theta. Okay, this formula, it is saying perpendicular means you can take 90 degree, and you know guys that cos 90, this will be I by 2, right? I naught is nothing but I by 2. Cos square 90 degrees is nothing but what? 0. So this will be 0. So option 1 is correct. I hope so you like this video, and if you, please share it with your friends and give me your feedback in the comment section so I can bring such more interesting videos. And the next set of video will be discussing this diode and logic gates problems. Okay, so thank you for watching and share your feedback so that you can get more such videos. Thank you.